Okay, we're going to look at some integration now. Integration, remember, being the inverse process of differentiation. So let's start with an easy example. X to the power 6. So remember, for integration you add 1 to the power divided by your new power, and for indefinite integrals, that is ones that do not have limits, we add on the constant of integration. So x to the power 6, add 1 to the power, gives you x to the power 7, divide by your new power and add on the constant of integration. So what about x to the 19? Well, that's x to the 20 over 20 plus c. Example 3, we're going to integrate x to the minus 4. So add 1 to the power, divide by the new power, x to the minus 3 over minus 3 plus c. Example 4, x to the minus 11. So that will be x to the minus 10 over 10 plus c. Okay, at this very early stage we're going to look at changing negative powers back into positive powers then. So we'll integrate x to the minus 12. So that will be x to the minus 11 over minus 11 plus c. So remember, that's 1x to the minus 11, so I'm going to get the power to be positive, and that will be 1 over minus 11 x to the 11 plus c. And that is using the reciprocal Relevancies, which is a to the minus n is equal to 1 over a to the power n. Okay, example 6. Let's integrate t to the minus 8. So that will be t to the minus 7 over minus 7 plus c. And then let's tidy that up, and that will be minus 1 over, bring that down, 7t to the 7 plus c, example 6. I'm going to integrate p to the minus 100. So that's p to the minus 99 over minus 99 plus c, which will be minus 1 over, bring that down, 99 p to the power 99 plus c. Okay, let's try some with fractions in it. So I'm going to integrate x to the power 3 over 2. So that will be x to the 5 over 2, since 3 over 2 plus 1 is 3 over 2 plus 2 over 2, which is 5 over 2, divided by 5 over 2 plus c. I'm then going to bring the fraction up and flip it over, change the divider into a multiply, and that will be 2/5 x to the power 5 over 2 plus c. And that can be written as 2/5 of the square root of x to the power 5 plus c. And I'm using that Relevancies there. A to the power m over n is equal to the nth root of a to the power m. Okay, let's try another one, which will be p to the 7 quarters. So add 1 to the power, 7 quarters plus 1, which is 4 quarters, which is then 11 quarters. P to the 11 quarters divided by 11 quarters plus c. Bring the fraction up and flip it over, change to multiply, 4/11 of p to the power 11 over 4 plus c. And then again, using this rule of indices, that can then be written as 4/11 of the 4th root of p brought to the power 11 plus c. Okay, we're going to integrate g to the minus 2/3. So add 1 to the power, that will be g to the 1/3, and that's because minus 2/3 plus 1 is minus 2/3 plus 3/3, which is 1/3. G to the 1/3 divided by 1/3 plus c. So 1/3, flip it over, that will be 3 over 1, which is 3g to the 1/3 plus c, which is 3 lots of the cube root of g plus c, since a to the 1 over n is equal to the nth root of a. Okay, let's try another. So let's integrate 5x to the 4, so now there's a constant in front. So that will be 5x to the 5 over 5 plus c. These two cancel out and leave me with x to the 5 plus c, example 11. we're going to integrate 4t to the minus 3. So that'll be 4t to the minus 2 divided by minus 2 plus c. 4 over minus 2 is minus 2, so that's minus 2t to the minus 2 plus c. Bring the power down, and that will be minus 2 over t to the positive 2 plus c. Okay, example 12, we're going to integrate 5. So if you integrate a constant, you'll get a constant x plus c. Going to integrate minus 0.4, so that will give me minus 0.4x plus c. If we were to integrate, for example, root 2, we would get root 2x plus c, or if we were to integrate, for example, pi, we would get pi x plus c. If you integrate a constant, you get a constant x. Okay, let's try example 16. I'm going to integrate 7x to the 3/5. So that will be 7x to the 8/5, since 3/5 plus 1 is 3/5, plus 5/5, which is 8/5, divided by 8/5 plus c. Bring the fraction up, flip it over, and that will be 5 over 8, 5/8 times 7x to the 8/5 plus c. So that's now 7 5s are 35, 35 over 8, lots of the 5th root of x brought to the power 8 plus c. Okay, we're going to integrate minus 5 theta to the 2/3. Okay, so add 1 to the power, that will be 2/3 plus 3/3 is 5/3, divided by 5/3 plus c. Bring the fraction up, flip it over, that will be 3/5 lots of, or minus 3/5 lots of 5 theta to the 5/3 plus c. Okay, so those two will cancel out, and that will give me minus 3 theta to the 5/3 plus c, which is minus 3 lots of the cube root of theta brought to the power 5 plus c. Okay, example 18, let's integrate multiple terms. So we're going to integrate x to the 5 plus x squared. So we just integrate each in turn. That will be x to the 6 over 6 plus x cubed over 3 plus c, example 19. And we're going to integrate x to the 11 plus x to the minus 4. Okay, so that will be x to the 12 over 12 plus x to the minus 3 over minus 3 plus c. So x to the 12 over 12 is fine, but I can bring that back down, and that will be minus 1 over 3x to the positive 3 plus c. So if you use the reciprocal rule, we bring that back down. Okay, let's integrate t to the minus 3 plus t to the minus 6. So that will be t to the minus 2 over minus 2 plus t to the minus 5 over minus 5 plus c. Remember that there's ones up here. So I can bring t to the minus 2 and t to the minus 5 down and change the power. So that would be minus 1 over 2t to the positive 2 minus 1 over 5t to the positive 5 plus c. Okay, example 21, we're going to integrate minus 5x to the 7 plus 8. So that's minus 5x to the 8 over 8 plus 8x plus c. Example 22, we're going to integrate 4r to the 2/3 minus 9r plus 5. So that will be 4r to the 5/3, since 2/3 plus 1 is 2/3 plus 3/3, which is 5/3. Remember, there's a power of 1 there, so that's minus 9r squared over 2 plus 5r plus c. I can then tidy this up a wee bit, so that will be 4 lots of the cube root of r to the power 5 minus 9r squared over 2 plus 5r plus c. Okay, we're going to integrate g to the minus 9/5 minus g to the minus 2/5. Okay, so minus 9/5 plus 5/5 is minus 4/5, so that's g to the minus 4/5 divided by minus 4/5, and that will be minus g to the 3/5, since minus 2/5 plus 5/5 is 3/5 divided by 3/5 plus c. Okay, so let's bring the fraction up and flip it over. That will be minus 5/4 g to the minus 4/5 minus 5/3 g to the 3/5 plus c. Okay, so let's tie this up. So I can bring this back down, so that will be minus 5 over 4 lots of g to the positive 4/5 minus 5/3 of the cube root of g to the power 5 plus c. So it's minus 5 over 4 lots of the 5th root of g to the power 4 minus 5/3 of the cube root of g to the power 5 plus c. Final answer. Okay, let's try one final one. I'm going to integrate minus 15x to the minus 2 plus 10x to the minus 5 over 2 plus 5x to the minus 3. So add 1 on the power, divide by the new power. That's going to be minus 15x to the minus 1 over minus 1 plus 10x to the whole minus 5 over 2 plus 2 over 2 is minus 3 over 2 divided by minus 3 over 2 plus 5x to the minus 2 divided by minus 2 plus c. Okay, so that's going to be, those two negatives cancel out, 15x to the minus 1. Bring the fraction up, flip it over, that will be minus 2/3 of 10x to the minus 3 over 2 minus 5 over 2x to the minus 2 plus c. We can now tidy it up. So that will be 15 over x to the 1, which I can just leave as x, minus, well, 2 times 10 is 20, 20 over 3, 20/3, but I'll bring the power back down so that's beside the 3 to the power 3 over 2. I'll bring that back down, so that's minus 5 over 2x squared plus c. Final answer, 15 over x minus 20 over 3 lots of the square root of x cubed minus 5 over 2x squared plus c.